Hello everyone, and welcome to Jam Academy. In this example, a cube of mass m lies on a turntable rotating at a constant angular velocity omega. We are required to determine the maximum angular speed before the cube slips outwards, and we also have to explain why. In other words, if the angular speed of the turntable is slowly increased, at some instance the cube will actually fly outwards in a straight line. So the question is, why is that the case? Now, for you to be able to see exactly why, we have to start first by drawing our free body diagram. Now, the cube is rotating in a circle, and therefore it is performing circular motion. That means that it has a centripetal acceleration. And by Newton's second law, for a system to have an acceleration, there must be a net force acting on that system. There must be a net force acting on that system, and the direction of the net force is the same as the direction of the acceleration of the object. That means that the net force acting on the cube is directed towards the center of the cube. So the question that should be in your mind is, what then provides, or what is the centripetal force in this particular instance? For you to see the answer to this question, let's start first by doing our free body diagram. So the weight of the block is vertically downwards. There is a normal force acting upwards, and the block has a tendency to skid outwards. That means that there is a force preventing it from sliding outwards. Therefore, that force must be acting inwards. And so we have here a static friction force acting inwards. So if we draw our free body diagram, this is static friction. This is the weight, and you have here the normal force. So by definition, we know that the sum of all forces in the y direction, this is equal to n minus mg, that will be equal to 0. So n is equal to mg. The normal force acting on the block or on the cube is equal to the weight of the cube. By definition, we know that F of s is less than or equal to mu s n. In other words, F of s is less than or equal to mu s mg. Now, let us sum the forces in the direction of the centripetal acceleration. We know that the summation of Fr is equal to mar, which would mean that F of s is equal to mar. In other words, F of s is equal to mr omega squared. mr omega squared. Now, there are two equations I would like for you to take a look at, which are very important for you to understand why the cube will skid outwards after we reach a certain value of omega. Let me label this equation 1 and equation 2. From equation 1, f of s has a maximum value that it can attain. F of s has a maximum value that it can attain, and that maximum value is given by mu s mg. Now, that means that if the centripetal force required to keep the cube moving in a circle exceeds this maximum value, the cube will slide outwards. Now, when you look at equation 2, as omega increases, f of s also increases. That means that as we continually increase or gradually increase the angular speed of the cube of the turntable, the centripetal force required to keep the cube moving in a circle consequently will also increase. Hence, if we continue to increase omega, there will come a point in which the centripetal force required is greater than the maximum static friction. When that is the case, there will not be a sufficient force to compel the cube to move in a circle. At that particular point, it will skid outwards in a straight line in accordance with Newton's first law of motion. So that means that that Fs max, which is equal to mu s mg, will be equal to mr omega max squared. The m's will cancel, and the maximum angular velocity that we can have and the system will not skid is given by this particular expression. It's given by this particular expression. Well, thank you so much for your time. I really do appreciate your time and commitment for this course. I look forward to the next lesson. Bye-bye.